Good morning, friends. Up to this, we discuss about the MCQ question asked in Neet and also All India PMT. Today, we have also considered some MCQ question remaining for Neet and also the MCQ question asked in past exam of Woodset. Now, next question is the surface which does not reflect is given. Incident light with the 18 watt per centimeter square energy flux. On this surface, that much light with this energy flux is incident. Then what will be the pressure? What will be the pressure act on this surface? One surface is given that not reflect the energy. All energy is absorbed by the surface. On this surface, the light with the energy flux 18 watt per centimeter square is incident. So what will be the pressure produced on this surface? Now listen, here the energy flux is given in CDS. That means the 18 watt per centimeter square. Convert into MKS 18 into 10⁴ watt per meter square. Because the 1 centimeter is equal to 10⁻² and square of this, therefore 10⁻⁴, taken on numerator, so it becomes the 10⁻+4. Now the pressure P is equal to energy flux upon speed of a light divided by speed. Therefore 18 into 10⁴ upon 3 into 10⁸. 6 3 are 18, so 6 into 10⁻⁴ Newton per meter square. So this numerical we are not actually not considering in this. That is depends on the wave. The energy incident on the surface, so what will be the pressure? Already we discussed about the characteristic of photon. So photon is also produce the pressure. So that much pressure is act on the surface on which the energy flux incident. Okay. So 6 into 10⁻⁴ Newton per meter square is the answer. Now next, for a concave mirror, the image obtained at D2 from mirror for object at distance given. The focal length of the mirror will be. Now what it says that one mirror is given. Due to this mirror, the object is placed at distance d1 and image is obtained at distance d2 from the mirror. So what is the focal length? So for that purpose here, all the answers are given in terms of the d1, d2, d, right? Okay. For that purpose, we are using the mirror formula. Mirror formula is 1 upon F is equal to 1 upon U plus 1 upon V. Now, as we simplify it, we obtain F is equal to UV upon U plus V. Now, taking U as F plus D1 and V is equal to F plus D. Substitute this value. Therefore, F is equal to U plus D1. Sorry, F plus D1 plus into F plus D2 upon F plus D1 plus F plus D2. So here we are taking the object distance as F plus D1. Focal length plus object distance and image distance is also F plus D2. Therefore, F plus D1 into F plus D2. Here we substitute the value of U and V, and also in denominator U F plus D1 plus as it is. Now V is equal to F plus D2. As we simplify, we obtain under root of D1, D2 is that. So focal length of the mirror is under root of D1, D2. Clear this? Okay. Now next is a real object is placed at distance f from the pole of a convex mirror in front of the mirror. If the focal length of the mirror is f, then distance of the image from the pole of the mirror is. Now from this numerical, here we are considering the numerical asked in good set example. Real object is placed at distance f. That means the object distance is given as f. U is equal to minus f. Minus f. In front of the convex mirror. If the focal length of the mirror is f, then distance of the image from the pole of the mirror is. We have to find out the v. F is also f. We are using the mirror formula. From mirror formula. Mirror formula is 1 upon f plus 1 upon u is equal to 1 upon u plus 1 upon v. Therefore, 1 upon v is equal to 1 upon f minus 1 upon v. Therefore, 1 upon f minus 1 upon f, that means the 2 upon f, 1 upon v is equal. Therefore, image distance is equal to f by 2. Image distance is f by 2. There is, okay. Again, the real object is placed at distance f from pole of a convex mirror in front of a convex mirror. If the focal length of a convex mirror is f, then what is the distance of the image from the pole of the mirror? So here there is also given like this way. The real object is placed at distance 2f. Distance 2f from the pole of the mirror, or the f by 2 from the pole of the mirror. So this type of the numerical is asked by changing here the object distance, either f to f or f by 2. So corresponding we have to find out the distance of the image from the pole of a mirror. Clear this? Okay. Now next numerical is a spherical mirror gives real image 3 times greater than the object. If the distance between the object and image is 100 centimeter, then what is the focal length of a mirror? Spherical mirror gives the real image 3 times greater than the object. Therefore, magnification m is equal to v upon u. That is given the 3. Therefore, v is equal to 3u. V is equal to 3. Now, if the distance between the object and image, but u plus v is given the 100 centimeter. Substitute value of v, so u plus 3u is equal to 100. So 4u is equal to 100. So u is equal to 25 centimeter. U is equal to 25 centimeter. We require the focal length. Now, focal length we have to find out. Magnification given, u is given. Already we derived the equation of relation between the magnification, focal length and object distance or the image distance. So using this equation, m is equal to f upon f minus u. M is given 3 is equal to f upon f minus 25. Therefore, f upon f plus 25. Therefore, 3f plus 75 is equal to f. Therefore, 2f is equal to minus 75. Therefore, f is equal to minus 37.5 centimeter. So this type of the numerical are most important. Here the magnification is given. That means the spherical mirror gives the real image 3 times greater than the object. Therefore, HI is 3 times more than the HO. Therefore, M is equal to 3. And we also know that M is equal to V by U. And the distance between the object and image is given the 100 centimeter. Then, what is the focal length of a mirror? So, by using this concept, magnification is equal to V by U is equal to 3. Therefore, V is equal to 3U. Now, the distance between the object and image is 100. Therefore, U plus V is equal to 100. Therefore, U plus 3U is equal to 100. Therefore, we obtain the U is equal to 25 centimeters. Now, magnification no one, we have to find out the focal length. U is also obtained. Therefore, M is equal to F upon F minus U. Substitute the value U. 3 is equal to F upon F plus 25. Therefore, we obtain the F is equal to minus 37.5 centimeters. Okay, now next numerical asked in good set, right? 2006 and so on. Now, focal length of a plane mirror. Already we discussed about the convex lens and concave mirror and also the convex mirror. Frequently we are using the word focal length. Right? Mirror are 3 types: plane, convex and concave. What is the focal length of a plane mirror? So what is your answer? So now listen, first thing, here for a plane mirror is this surface, straight line. So radius of curvature is what? What is the radius of curvature? Infinite or 0? Here the radius of curvature is infinite, therefore the focal length of a plane mirror is also infinite. Instead of the focal length, suppose the radius of curvature is given. Radius of curvature of a plane mirror is, that also answer is infinite. Clear this? Okay. Now, two thin lenses of focal length f1 and f2 are in contact. The power combination is. That means what is the equivalent focal length of this combination of two thin convex lenses? Here two thin convex lenses. So here our simplification is 1 upon f, that is the power is equal to 1 upon f1 plus 1 upon f2. Right? Now listen. Equivalent focal length, just make here. The focal length of combination. Focal length of combination. Now 1 upon f is equal to 1 upon f1 plus 1 upon f2. We take the LCM, so in denominator f1 f2, in numerator f1 plus f2. Therefore, f is equal to f1 f2 upon f1 plus f2. And power is f1 plus f2 upon f1 f2. Understand or not? Power is the reciprocal of the focal length. Focal length is this f1 f2 upon f1 plus f2. While the power is f1 plus f2 upon f1 f2. Only the simplification of the resultant focal length of combination of the focal length of two convex lenses. Resultant focal length of combination of two thin convex lens. 1 upon f is equal to 1 upon f1 plus 1 upon f2. Okay. After that, a critical angle for a medium is 60 degrees. Then the effective index of the medium will be. We know the relation between the effective index of a medium and critical angle. N is equal to 1 upon sin c, or the sin c is equal to 1 upon n. We require the effective index of medium. Here the critical angle of a medium is 60. So 1 upon sine 60. Sine 60 1 root 3 by 2. Root 3 by 2. Therefore, effective index is 2 upon root 3. 2 upon root 3. So this is asked in 2006. Earlier numerically asked 3 times 2006, 8 and 18. 8 and 18. Again here, the critical angle for median is given 60. That means the C is equal to 60. We have to find out the effective index of a medium. So we know that for total internal reflection, the condition sin C is equal to 1 upon n, or n is equal to 1 upon sin C. C is given 60, so 1 by sin 60 is equal to 1 upon root 3 by 2. Therefore, 2 upon root 3. Now next is, a wavelength of a monochromatic light in vacuum is lambda. It travels from vacuum to a medium of absolute effective index. The ratio of wavelength of incident to the reflected ray is. Again, a wavelength of a monochromatic light is given lambda in vacuum. It travels from vacuum to a medium and the effective index is n. The ratio of wavelength of incident to the reflected rays. So, absolute effective index mu is equal to C upon V. Mu is equal to C upon V. Now, wavelength in vacuum is lambda 0 or the lambda. And now in given medium is lambda. So C is equal to lambda f upon, here lambda 0 f upon lambda f, f cancel, therefore lambda 0 upon lambda. Lambda 0 is the wavelength in a vacuum and lambda is the wavelength in a medium. Lambda dash 3. Therefore lambda upon lambda dash is equal to mu upon 1. The ratio of the wavelength of incident light to the reflected light is mu upon 1. For the mu is to 1. Now, for a prism of reflective index 1.732, the angle of minimum deviation is equal to the angle of prism. Then the angle of prism is, that is asked in Wilson 2009. Here we know that n is equal to sine a plus delta m by 2 upon sine a by 2. But delta m is equal to a. Angle of minimum deviation is equal to a. Therefore, n is equal to sine 2a by 2 upon sine a by 2. So it's equal to sine a upon sine a by 2. Now from the equation, we know that, so n is equal to 2 sine a by 2 cos a by 2 upon sine a by 2. That is cancelled. Now substitute the value of n. Therefore cos a by 2 is equal to n by 2. Cos a by 2 is equal to n by 2. That means the 0.86. Cos a by 2 is equal to 0.866. So it's equal to 60 degrees. Therefore a by 2 is equal to 60. Because the cos 60 is equal to 0.866. Therefore a by 2 is equal to 60. So a by 2 is equal to 30. Cos 30 is equal to 0.866. And therefore E is equal to 60. A is equal to 60. Again, the n is equal to sin a plus delta m by 2 upon sin a by 2. But delta m is equal to a. Therefore, n is equal to sin a plus a by 2. That means the 2a by 2. That means the sin upon sin a by 2. Now, we are applying the sin a. 2 sin a by 2 into cos a by 2, sin a by 2, sin a by 2. Cancel. N is equal to cos a by 2. 2 cos a by 2. Take the 2 in this side. So, a by n is equal to 1.732. Again, 2 cos a by 2 is equal to n. N is equal to this value. Divided by 2, that means the 0.866. 0.866, 0 is the cos 30. Cos cancel. A by 2 is equal to 30. Therefore, E is equal to 60. So, this is the prism angle, or the angle of prism for a given prism. That is asked in 2009. Now you could say 2010, the magnifying power of a telescope is m. If the focal length of the eyepiece is half, then magnification power is. So magnification of a telescope m is equal to f4 upon f. Now, f e dash is the half of its original value. So what's happened? New magnification, the new magnifying power, that is the m dash is equal to f4 upon f dash. Therefore, m dash is equal to f4 upon f by 2. That means the 2 f4 f. But f4 f is equal to m. Therefore, 2m. Therefore, magnification power becomes the double. If the if the focal length of the eyepiece becomes the half. Again, there is asked in 2010, the magnifying power of a telescope is n. If the focal length of the eyepiece is half, then the new magnifying power. We know that magnification of a telescope is equal to focal length of objective to the focal length of eyepiece. Now we make the focal length of eyepiece is half. F dash is equal to f by 2. Therefore, new magnifying power m dash is equal to f4 upon f dash. Therefore, m dash is equal to f4 upon f by 2. Therefore, 2 f4 upon f. Therefore, m dash is equal to 2. Clear? Okay. Now, next, also asked in 2010, a plane mirror produces a magnification of. What is the magnification of a plane mirror? We know that m is equal to f upon f minus u. For a mirror, plane mirror, f is equal to infinite. Therefore, infinite upon infinite minus u. Infinite upon infinite, that gives the plus 1. So, magnification of a plane mirror is 1 because we have the experience, whatever the image, whatever the object, the same image is formed by the plane mirror. But mathematically, m is equal to f upon f by u, f minus u. For a plane mirror, the focal length is infinite. We substitute the value infinite upon infinite minus u. Infinite is very large value. As we subtract the q value, u is very small. Therefore, infinite upon infinite. So that gives the plus 1. So very easy, very the concept about the theory is clear. So we can calculate any type of the numerical depends on the theory. And for the preparation of the Neet or the good set, the theory must be prepared first and also a concept must be clear.